to keep you guys going through both types. We need to, I don't want to just focus on exponential functions because I don't want you to lose all the stuff you know about linear equations. Or I don't want you to merge the two together, right? Like we talked about, we need to have these two distinct groups. Come on, just hold on. Okay? I'll take care of it. I'll take care of my sharpening pencil. Okay. Yeah. I said that was fun. So we have to have two distinct groups. We have linear functions and we have exponential functions. And the goal here being that you guys understand the difference between the two and they have their own little spots in your brain. Okay, what's really, really heartbreaker for me, like we talked about last week and we're going to look at your homework again, is when you write a rule that is, you're trying to write it as both linear and exponential, that's bad news bears. Okay, so we're going to work on that. Don't ask the whole class that question. You need to learn some skills. Don't ask in front of the whole class. Don't ask in front of the whole class. No, figure it out. How about that? Absolutely graph it, but I also want to look at some other ways to do it. I'm going to do the algebraic way. Okay? So the way I'm going to do this, we know, Ansel, you need to stop interrupting me. Do you understand? That it's rude and not funny? Do you understand that? Okay? So, like similar to exponential functions, linear functions have a slope and a y-intercept, and those are the two things that we need.
Yes.
Okay? So the first thing I need you to do is find the slope. That's going to be the first thing we do. We're going to find the slope, and because I can, and you guys, most of you already graphed it, I'm going to do that algebraically. I'm going to use my slope equation. I don't have to. I could also look at my 2 points, and I could try and visualize them on the graph. Okay? I could try and think about, okay, the x's are increasing. I can see that from the x from 3 to 6, the x's are increasing, and the y's from -2 to -7 are decreasing. But I'm going to use my slope formula today, just because we haven't seen it in a while. I'm going to subtract the y's, and I'm going to subtract the x's. Right, so I can go ahead and label this to help me out if I wanted to, x1, y1, x2, y2. So that when I'm using my slope formula and I plug in my points, I have -7 minus -2 over 6 minus 3. There is no reason, absolutely zero reason, why you should get a wrong answer here. Okay, I don't care if you are not sure about the rules of negative numbers because you have a calculator. So there's no reason you should have a computational error, right? You should use a calculator, okay? So here when I'm looking at this, -7 minus a -2, it's +2, that's -5, and 6 minus 3 is 2. So that's my slope. You guys don't get crazy. 6 divided by 3 is 2, like I said, but I'm not dividing, I'm just throwing it out there for funsies.
What is that?
6 minus 3 is, of course, 3. If you got a +5, then you should have a -3 on the bottom. Yes. Yes. Did you do -2 minus -7?
Because, no, I did 3x minus 2y equals 6x minus 7y. And then
That's not a thing.
Yeah,
It's not.
that is kind of that same answer.
Clearly you didn't, because you just said you got +5.
I don't know. Because I distributed it. I said 6, I moved 3 over here, 6 minus 3 equals 3. And then I did the same thing.
6 minus 3 equals 3. Or, wait, what?
You've got to go, so you've got to go the same direction right there. So if you want to do 6 minus 3, that's fine. Like, that's 3, but then you should do -2 or -7 minus -2. That +7 that you're doing, you can't go backwards like that. You're doing all kinds of voodoo math. I'm trying to make your voodoo math make sense to you. There's no, you made, like, that isn't a thing. I can try and help you make your method make sense, but You, no, you didn't. Okay, yours is right. I'm the one who grades it, so I don't know why. Dude, oh my god, your attitude floors me. Okay, there's your slope. The next thing we need is the y-intercept.
Which means you.
Okay, there's a bunch of different ways we can do this. Again, I could graph all those points. I could work on a graph. Mod, shush. Okay, what I'm going to do is use the algebraic way. I know that the general form for my line looks like this. I guess I'll do mx plus b just for fun. Okay,
Yes.
I know the slope. I need to find the y-intercept. The y-intercept is what I am solving for. I'm going to take my x and my y, and I'm going to plug it in order to help me find the y-intercept. Normally, I would not plug it in, right? Normally, my equation wouldn't look like that. But I'm going to do that today. So I have negative 2 equals negative 5/3 was my slope, times x was 3, plus some sort of b value. Again, you might not like fractions. You might not like negative numbers. Neither of those things really matter because you should be able to just put that in your calculator as negative 5/3. You have to know how to put fractions in your calculator. You must use parentheses. Times 3 is negative 5. Yes, you could also learn how to multiply fractions and they cancel each other out. So, negative 2 equals negative 5 plus b. Simply solving by adding 5 to the other side, I get that my y-intercept is 3. So whether you were on a graph or you were doing it algebraically, you have now a slope, you have a y-intercept, so that you can write the final equation of your line. And yes, I'm going to throw it into function notation just because I can. The final equation of our line, f of x equals negative 5/3 x plus 3. Great. So that's like some old school, really algebraic, really vague looking stuff, right? I think it looks, if you did it on a graph, it is much more clear. Anyone have no graphs?
I did a graph to get the y-intercept.
So, again, it's okay, right? All of that, I think, hey, I don't feel like I should have to constantly ask you guys to not interrupt me. Let's be clear. You have ample time in this class to talk to each other, where I won't interrupt, like where I give you space to talk to each other. I don't think any of you can in good conscience say that we sit here for an hour and a half each day and I talk the whole time. I don't talk the majority of the class. The majority of the class, you guys are working together, talking. There's all kinds of off-topic conversation, and I don't say anything because I think that you need that space. I'm not trying to like cram your brain to force you to sit there and be quiet. But when I am trying to give you a set of directions or talk about something or review something, I would ask that you could be a little bit more respectful. Because I'll just be honest. In my class of 50 freshmen, I don't have to ask them to be quiet as much as I have to ask you guys to be quiet. All of these tables are full in my periods after class, after lunch. And they don't sit there and interrupt me. Okay, you know the deal. You know that I'm not going to talk to you for very long. I've never talked to you for like maybe 20 minutes once. I don't even know. Okay, so please have a little bit more respect on that. Okay, in the very least, if you think that you don't want to pay attention, then just be quiet. Okay. What I'm pointing out is that this I don't know, this doesn't make, when I was in high school and still, like, that doesn't really make a ton of sense to me. Like, I'm much more visual. This makes a lot more sense to me, right? When I can see it, that makes great sense. We have the 2 points. I can see that from left to right, my line is decreasing. I can see that it goes down 5/3. And if I look backwards, I can clearly see a y-intercept of 3. That's fantastic, okay? That's a lot more clear. But the reason this is a limitation, we can't always graph it, especially once we get into real life numbers, especially like what we're going to see today with car values and stuff. We're not always going to graph it, but when we can graph it, it sure is a heck of a lot nicer, okay? So either way, the graph matches what we found. We have a negative slope, we have a positive y-intercept, all things good, okay?
Yay.
Looking at your homework real quick,
I was confused at first.
you should be able, again, linear, I think it's easier. Like, you learn about linear equations first, and starting in way back when, like 6th grade or something, because they're a little bit easier. Check to see if there's a constant being added. You should be able to notice pretty quickly, like hopefully number sense, even if you don't know that 8 plus 12 is 20, you can see small jump, big jump, right? Like, hopefully if I was like, is 8 and 20 the same as from 20 to 50, you should be able to be like, no, because numbers, right? So here I can already see, like, I don't even need to check that it's adding. It's clearly not adding the same thing each time. Let's talk about how to find a multiplier. How to find a multiplier. What?
You can take the 20 and divide it by 8.
Mm-hmm.
Figure out like how much is going by. Yeah. And then you can check to see if that's the same as 50 divided by 20.
Okay, 20 divided by 8 times 2.5.
Yeah. And then you can see if 20 times 2.5 is 50.
And is it?
Yes, because it says here
Okay.
divided by itself is 20 times 2 is 40.
Awesome.
And 50.
Awesome. So we have a multiplier.
Yes.
And it works for those two. So I could go ahead and fill out the rest of the table. I'm
Yeah.
sure that you guys could do that. I'm not going to. And then I would write my rule. You'll notice right here, I also could use some different numbers for n or x and t of n.
You can make
So
it down.
this is just said as t of n, same as f of x. There's all kinds of different notation. So here, technically based off the table, your rule should have been t of n equals, it starts at 8, and you're multiplying by 2.5 to the power of x. That one, oh, good call. To the power of n. Not technically,
Are you
no.
gonna mark it down?
Don't, I don't want to say that. No, I wouldn't. No. If it was the same thing, I would.
T and N.
Yeah, if you wrote an n here and then an x here, your equation makes no sense.
That's T and
Sure. Okay, so looking at the second one, looking for, I'm always checking first to see if it's linear. Is it adding or subtracting? Here I can see, great, that's -4. Awesome, that's -4 again.
Linear.
Fantastic. It's linear, fairly straightforward. Of course, we need to go backwards though to find our y-intercept, right? Things we've done before. This would be 20, this would be 24. So then my rule here would be t of n is equal to 24 minus 4n. Making sure that you didn't write your 4n as an exponent, that weird things didn't happen with your notation. Notation seems not very important, but in fact it is. Okay? That's fine too. It doesn't really matter. Okay. Last one. Again, I can see 12 minus 3 is 9, but 9 minus 3 is not 6.5. So I'm going to figure out my multiplier again, and I'm going to do that the same way we did up here. Okay? So when I do that, when I do 9 divided by 12, I get that I'm multiplying by 0.75. And I could check that, right? And I can see that 12 times 0.75 is indeed 9, and 9 times 0.75, hopefully, is 6.75. So now I have found my multiplier. I'm multiplying by 0.75. Hush. So if I wanted to go backwards, of course, instead of multiplying to go backwards, I'm going to divide. Divide by point. What? Okay. So going backwards, 12 divided by 0.75, you get 16. And then you can write your equation. Right, so now we have our equation that t of n, make sure you have the right notation, 16 times 0.75 to the power of x.
And
N. Haha. I don't know. Okay. I know. Okay. So make sure your homework is good. Now, see what we're gonna talk about. Cars. Buying cars, specifically. First thing, let me tell you one of the dumbest things you could ever do. One of the dumbest things that you could ever do financially is buy a brand new car. Okay? Why? Anyone want to guess why it's a bad idea to buy a brand new car? Stand up. Okay, they're overpriced.
you could pay, let's say, if you and, yeah, you can, like, you can spend the same money on another car, I guess. Like,
What do you mean,
don't
another
waste
car?
as much money as on a brand new car.
Okay, here's the deal. When you buy a brand new car, right, has less than like 50 miles on it. There's like no miles on it. What happens when you drive off the lot? What kind of car do you have now? A used car. Like in that moment. They say like they lose up to like 10% of their value sometimes, that like the minute you drive it off the lot. Now if you sold it back, you're selling a used car, and now it loses value. Because cars over time lose value. True statement? All cars over time lose value. What's the difference? Exception to that rule. Right? Nice car, like older cars or cars that are like collector cars or Huh?
They'll pay more money.
yeah, right. Some cars, they certainly maybe have lost value for some time, and then they turn into that. Now they're a vintage car, they're a model car, and then antique cars. Now they start gaining value again. But today we are going to talk specifically about cars losing value, called depreciation. We're going to look at this the same way we looked at savings accounts. So, true story, Honda Civic, I looked it up, Honda Civic LX, the least fancy model you can get, starts at $18,670. 2016, Honda Civic. Okay, but it loses roughly 12% of its value each year. Okay, so each year, which is why you can go, like I just bought a 09, and I did not pay the price that someone paid in 2009 for it. I paid it much lower.
Does that mean the insurance?
Also-
Will the insurance stay the same then?
Insurance, will the insurance stay the same? Yeah, you probably don't want to, Civics have really high insurance because they're often stolen for parts. So you don't, it's true. Honda Civics are stolen. Okay, so what you're looking at is I want to know the value of this car. King, are you awake? Awesome. So it's similar to the work we did with the savings account. Starting out slow, calculating the value lost each year. That year zero, make sure you don't get crazy. That year zero, we're saying this is 18,670. Right? So that after year one, you're starting with, hey, the starting value is $18,670. What's 12% of that, and how would it get lost? Okay, you're losing that percentage. So calculate 12%, subtract it out. Calculate 12%, subtract it out, and repeat that process. To calculate 12%, you're multiplying by 0.12 to calculate 12%. So if I want 12%, yeah. So 12% of 18,670 is 2240. So 2240.40 cents. Remember, we're talking about dollars. Use 2 decimal places, please. And so then I would subtract that out, right? 18,670 minus 2240.4, and I'd get my new value. And I put that here.
16, 4, 9, 3, 4. And then use that to do
Right? And it's going to be different each time.
16.16 for.
It's not cheating. If you don't want to do all that, find the first few, then find a shortcut. But you need to have this column done. I need to know the price after 12 years, and we're going to compare that with, yep, the old table. Mr. Harish, should we grab the iPads?
You do the one number, then you divide it by the number.
You don't need to, what?
To find how much it goes up by or down by, you take like the 16. You take this one.
Keep going, I think.
Well, here it is. Hey. Hey, I found it. Okay, so it's y equals.
Will you get one for each person, their boss?
6, 7, 9, times 0.88. That's
Okay. After 12 years, what'd you guys get as the price?
I got a lot.
Hold on. Well, then I'll wait till you get to 12. You need to be at 12.
Oh.
If you're done and you want to start graphing, you can. But there's no reason why we shouldn't be at 12. Because all of you, guess what? You know how to multiply and you know how to subtract. You have a calculator in front of you. So there's no reason you shouldn't be done. You're multiplying by 0.12, and then you're subtracting. Then you're multiplying that by 0.12, then you're subtracting. Do you need to not have that? Put it away. Stop taking pictures of yourself. You have like 2 seconds to close it and put it down. We're not using it right now. Multiply, subtract. Find out, I need to know how much you have in 12 years. How much it's worth in 12 years.
4,000.
Respect the other people when you're there yet. Also, put it away. You have your number?
I'm there.
Awesome.
I got one.
Are you done, Lorenzo? I got 5.8.
So it doesn't matter.
All right. So, depending on rounding, you might have a different cent number here. You should still have $4,026 though. Okay, now, despite my better judgment, we're going to try this. Okay, so let's suppose if you were gonna buy a 12-year-old Honda Civic, this would mean that's about how much you paid for it. Maybe. So 12 years ago was what year?
That was 2004.
2004. What you guys are gonna do is on the iPads. How many of you have heard of Kelley Blue Book? What's Kelley Blue Book, Maud? Kinda yes, kinda no. Yeah, it tells you supposedly what a fair price to pay for a car is. Okay, let me tell you, you'll rarely get a car at Kelley Blue Book value, but hey. So what we're gonna do, on your iPads, I want you to navigate to Kelley Blue Book.
I'm there.
And I'm not gonna walk you through this because I think that you are fairly savvy people. I want you to find the price. What's a fair price for a 2004 Honda Civic?
That was
12 years ago would be 2004. So what's a fair price to pay for a 2004 Honda Civic? That's your task right now. It's going to give you all kinds of options, all kinds of information. Guess what? You just need to kind of use your best judgment as you navigate through there. I'd like to try and find a similar. It was a LX.
I can't
It was a sedan, which means it has 4 doors instead of 2. No, I want a hatchback.
Wait.
I can't
You're not going to be able to get to this page. I'm simply giving the information on the car. You're not trying to choose a random car.
What's the location?
If you are not on Kelley Blue Book, I will take your iPad as soon as I see that you're not on it. That's how that works.
Yo. Oh, okay.
Okay. 5,000 to 7,000.
Try listening to me next week.
She said choose it whatever you want.
No, I did not.
She said you won't make it for
I said I based our price off the Honda Civic LX, which is a sedan.
We'll do
It
electric
has
car.
4 doors.
Oh. See, I didn't know that.
We'll do electric car.
I don't know car stuff.
4D stands for 4 doors.
That's why I'm telling you.
I said
That's
LX.
why there's a picture.
What are you doing?
She's an LX.
It's on a different website.
Select the style.
I picked it.
I want a manual. I would not die. Okay. 3,000.
Okay, so if we're looking at 2004 Honda Civic LX, let's try that one more time. Put your iPads down
Yes.
if you're not looking at it. Okay, I don't need to add a bunch of options. If I price that car and we say we're going to buy it from a dealer, we can also look from a private party. Okay, if I buy that car from a dealer, 2004 Civic, it tells you right here your fair market range is between 4,000 or 3,900 and 5,200, 3,800. Okay, and that the average price was $4,500. Okay, so one of the reasons you're looking at this is if you want to buy from a dealer, here's another lesson, versus if you buy it from a private party, you'll notice the private party is a lot cheaper.
Why is
Okay.
it private party?
Because when you're paying from a dealer, you're paying for all kinds of other things. But like if you are just buying from a private person who owns the car and wants to sell it,
Oh, okay.
they'll
Private
generally
party
sell it
is
cheaper.
different.
yeah, private party means someone who owns the car. Okay, so really either way though, we're looking at and what we can see is that this was actually accurate, right? A car losing 12% of its value a year, that's for real. Okay, so as you guys might start thinking about buying cars, my first car was a Nissan Sentra. It was 13 years old and my parents paid $2,500 for it. I don't drive it anymore.
Who sold to me?
It was a 92. I got it in 2005. It's really, that's a sweet wheels. But again, you know,
I'm gonna be driving a car.
there you go. See, it's kind of nice. Okay. Now
Look
here's
at
the
your drive.
here's the kicker.
I'm so close.
You are done with your iPad. Close them.
I bet fucking worse. I'm a little less like
Okay. This is frustrating to me. Can you just do what I asked you to do? Okay. So you have all these numbers. You have the data for the 12 years. Two things that I want. Okay. One, I want a graph. Specifically, I want 5 and 6. And then here's my next question. Okay. I want a graph, I want 5 and 6, and I want question 7 done. A graph, 5 and 6, and question 7 done. You have until 11:05. You have until 11:05 to answer these 4 questions. I don't mind if you guys work in your groups. I do mind that you do your own work. Again, these are going to be collected the same way your savings account was. Okay, so these are going into your grade. could you tell me if I was losing 6%, what my multiplier would be?
Haha.
0.94.
Hmm? Okay. So where did this come from? Go ahead, Maud. Yeah, it's this. Our multiplier was 12%, but here we were losing 12%. So like Maud just said, it's 1 minus the percent. So those notes that we took here for percent growth, right? For our percent growth, it was the initial times 1 plus the percent when it's growing. And again, this should make sense. Like, of course it's 1 minus the percent. When it's decaying, it's 1 minus. We're going to put that in our notes real quick. Okay? That's going in our notes. For A7,
Yes. I'm answering. Yes.
4% decay. Or depreciation. We're going to write the same thing. F of x is equal to the initial, whatever your initial value is, whatever your initial amount is, your initial, whatever the initial investment is, or whatever we're talking about. And then this time, it's going to be 1 minus the percent to the power of x. And then here's the deal, right? It should seem fairly obvious. When it's growing, we add the percent. When it's shrinking, we subtract the percent. Okay? The 1, again, comes from the idea of that whole, right? So those of you who did fill out the chart, when you did fill out the chart, you were finding the percentage and then subtracting it from the whole each time. Finding the percentage, subtracting from the whole. Finding the percentage, subtracting from the whole. Okay? So, I can use that to help me write an equation, right? If I want to write an equation, and I want to say then my equation would be, I started at 18,670, and I was multiplying by 0.88 to the power of x. So I need all of you right now, on your own individually, answer number 7. If you have this equation now, can you tell me how long, how many years until the car is less than $500? Okay? Make sure you show some. Those of you who think you're done, can you tell me exactly when it goes under 500? Exactly.
I will be able
Exactly.
To. I will be able to say.
Well, I mean,
Try and push it. Exactly when. You gotta put the caret. And then the 2 to the power of x. And then graph.
So for x.
We didn't solve for x. I'm sure that you did.
There's no graph.
Oh yeah, you can see.
Listen up.
Yeah.
Give me 3 minutes.
Okay.
Now that we know our multiplier, we know that I'm multiplying by 1 or 0.88. Here's the first method. I could go, that's 1. 2 years. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And I could keep counting like this until I get to under $500. Next method might involve what I see a lot of you guys doing if I were to guess. Your method would be something like this. You want to type this into the calculator, Hint, you should darn well know how to put this in the calculator. You should know that you need to have the exponent, you have to use the little caret to say to the power of x, okay? If I wanted to, and I think what a lot of you would do, is you'd put this in a table, and then you would keep scrolling on your table. You guys use the tables all the time. And you would see it somewhere in the year 28 and 29. Somewhere after between 28 and 29 years. This would not be 2028. Why would this not represent the year 2028?
Because we're starting to
Cool, because this one was 2016, sure. But, yeah. Okay,
I was just saying.
now my next question, though, was when's it exactly $500? Okay, some month in here. And there's all kinds of different ways we can do this. One way you can't do it, though, you guys,
Can't do it.
essentially what I'm asking you to do is I'm asking you to solve when is that going to equal 500? And guess what? Here's the hard truth.
You can't do it that way.
You can't solve this. Yeah, you can't. Yes. You will learn how to solve this next year.
Okay.
But,
If I take it.
well, you will learn how to solve it algebraically last year. But guess what? Full circle. Here's what we're talking about in the warm-up. Yeah, there's an algebraic way to do this. Just like there was in our warm-up. But just like our warm-up, it's a little bit easier if we just use a graph. Okay, so here's what we're going to do. All of you have a calculator. Please follow along. This is the last thing I want to do. We should have this typed in, and I want to make a graph. Okay, so I'm going to have it typed in, and then I'm going to change my window. If you just went and graphed it right now, you're not going to be able to see it because your window is at like -10 to 10, and clearly our graph is going up towards 18,000. Okay, so I need to change my window. So I'm going to go to window. I'm going to go to window. My X's, my years, I don't have negative years. And we just saw on our table that it's going to be somewhere between 28 and 29 years. So I'm going to make my maximum, my X max, 30. So I want to say all the way out to 30 years. Okay? The scale is just how many tick marks there are going to be. I could put a tick mark every one. I'm going to change mine to 5 just because I don't want a lot on my graph. Okay? Again, why minimum? Is this car ever going to be worth negative dollars?
They won't
Right?
They won't pay you to take it off.
They won't pay you to take it unless maybe the government does cash for clunkers again. Who knows? Okay.
What if it isn't?
Yeah.
They paid you to take stuff.
Didn't they pay for your car? Yeah. They
Wow.
cash for clunkers.
I take a
Okay.
I'd take everything.
But it's never going to be a negative value, right? No one's going to be like, hey, like, I'll pay you. Give me your, or like you pay them to buy your car. Like you don't, okay.
I'll take your car here.
The maximum value, probably,
20.
right? Honda Civic Hybrid. Is there some version where maybe in many moons they're like, ooh, look at that sedan, and then it like starts gaining value again? Sure, maybe, but it's probably not going to be higher than our initial value. We're only going down from there, and I'm going to make mine go by 2000s just because I don't want a lot of tick marks. Okay? If you left that at 1, you could. Your axes would just be a solid black line, and your graph would look ugly. Okay? So when I graph it. I see a nice, beautiful curve.
I'm gonna try the one.
Here's the problem. Here's what I want. I want to know,
It doesn't look bad. It's like
do we want to know when the X or Y is 500?
Why? Yes.
Do I want to know when the X or the Y is 500? Which one represents value?
I know. Why?
The Y. So get this. Back on our Y equals screen. Back on our Y equals screen. I want to know when Y is equal to 500.
oh, then you do the
Yep. So if I add that equation, now we'll have 2 graphs. You might say this is an exponential system of equations, where I have my curve and then I have another line. And I want to know the point right there where those 2 lines intersect.
So
Hint, intersect. I can calculate the intersection, by doing second calc. If I do second calc,
5.
it gives you that intersection the same way we used to solve systems way back when. If I intersect, and I have my two lines,
Here, 28.318.
we can, without knowing anything about what you'll learn algebra 3 4, logarithms, without knowing anything about logarithms, we can solve exponential equations. Okay? So here, by using my graph, I can see that it's exactly at 28.3. Did we get this part? Okay, so when I have my graph, I have my two lines, and I'm going to get the intersection of those two lines. So that's under calc. So I go to second calc, and I go to intersect, which is 5.
What's the
And it asked me 3 questions. It says first curve, and it tells you your first curve is this y equal. So you really just hit enter 3 times. Enter, enter, enter. Yeah. So it should be 28.3 if you hit it.
Sweet.
If you go second calc 5, enter 3 times, right? Hit enter again. It will say guess. It says first curve, second curve, guess. Enter, enter, enter. Cool. So, we'll be using that from now on. Please make sure that your stuff is put back. Some of you guys keep pretending that